really get messy. Okay. Ready to go. Switch to this scene. Yes. Oh, both the same cam. Oh. Doesn't go well. Wait a second. That works better. So, welcome to this stream. It's 6:20 here in Germany. It's dark outside already. I have this chat a while with some people in Facebook watching my video say, oh, it's still bright. No, I'd say it was in summer. It's there we have a lot of daytime. Now in winter, not so many daytime. But it's okay. So what is this video about today? Just let me put this away. Still need to clean up a little bit. And this video will be about my latest project. Doesn't go away. About the latest project with an Arduino controlled dollhouse lightning solution. Here's the prototype. Still works fine. And this is the PCB I made for it. Hope it will work. And wait. I found out I can zoom in with this software. I just need this. So it's the start is a little bit, how to say, as always, a little bit, not weird, but I didn't get out of this software. Oh, there's a way to get out of it. The start is a little bit long. Wait, I need to post one more time. So I want some viewers. Oh, don't. Then I have. Good. So, oh, I can monitor the chat with the iPhone. It looks like. Teilen. And I teilen it with where? Ah, there. And there. And maybe they will be upset. Doesn't matter. So, ready to go. Almost. The hand cam goes there. I will need it later. This is my stand for the hand cam. Oh, another cam. Here's the schematics. Schaltplan in German. Maybe I have some German viewers, so maybe I will speak a little bit German in this video, or not sure yet. Maybe only English. And the demo, the prototype, I think it can still stay here. So if I need to check something. Okay, for this project. A while ago, I built this prototype. I found the chip, good that I remember the number. What's the number there? The TLC from Texas Instruments. It is an LED driver chip. It has 16 PWM channels, so it can control each light individual with different brightness or with different brightness. So it has 16 channels, and the Arduino itself has not so many channels with the PWM support. And now they cannot monitor the chat. Yeah. Why it go? Doesn't matter. Sorry, a little bit have to concentrate and tell you about this. This is the important thing. So, 16 channel PWM controller. A normal Arduino doesn't have 16 PWM channels. It has some, but not so many. And I forgot how many. And so I can control 16 individual LED lights, and I don't need a resistor for each LED, because you set with one resistor. It's there on the board and there on the schematics, Schaltplan, to set the amps, the current, and it's set to about 20 milliamp. And so you can control each LED. It has 0 to 4,000 something steps. But to be honest, I set to about 16 steps in my software. 20, 60? I forgot. It's a long time ago that I explained also the code. So if you want to know more about the code, just check my other videos for this dollhouse LED light project. And you can see, or you can know how I write the code. I'm explaining the code. I'm explaining a little bit the schematics. And that's what we do today. We bring it from the prototype to the first PCB. The problem is, I didn't know if it works. It's the first time I will assemble this board. I waited a long time for it to arrive. The first one sent by PCB away just get lost somewhere. And it took them 2 months to send me new. But then they sent 5, they sent 10. So I have a lot of these boards, but not so many of the TLC, and I only need one board. And I guess I make one mistake I already found out. I think I mess up the DC inject something, but should be okay. The way I will assemble it, I will start with the parts for the power supply, then check the voltage. If this is fine, I will add the microcontroller, the Texas Instruments chip, and the display. It should be not too difficult. On this board, I have the 16 LEDs here, and also a header to go to the dollhouse, or it can also be a Lego house or a model house, a model railway, whatever you want to have control the light. The software is at the moment still in beta or alpha version, but it already allowed to switch on each light individually. It allows to flicker the light. Oh, I can show you the. I think this can go. Maybe you can see a little bit here. This is, by the way, is an RGB LED. So it flickers through all the cycles. It gives a lot of different colors. But you can also set it to red, blue, or yellow, green. Oh, forgot. Didn't know which channel this is. Oh, this is no channel. Then maybe 14. You can see I can just full, and 15. I think it is the red light, but I'm not sure. Also flicker off. Oh, just set it off. And I forget which numbers I use for this. Maybe 16. Off. So the channel 13 is the red light. Now it's red. You can see it a little bit, but you can let flicker each. And I guess for the RGB thing, I will rewrite the code a little bit, but not sure yet. So today it's all about assembling it and give my PCB the first test if it works or not. Maybe if it not work, we will do a little bit troubleshooting, but I don't want to make the video longer than 2 hours. So about 8 o'clock is Schicht im Schacht, is over. Maybe not. Maybe it makes so much fun that I stay longer, and I hope some of you will just join and have fun with me building those weird stuff. Okay, there are some viewers, not so many, but this is what I expect. Small channel, not very big. But to the assembly. Oh, the mouse I don't need now. Coffee is there. The iron need to be switched on. It goes to standby after a while. I was already talking too long. So display, the Arduino. Or maybe I should go through the parts. What do we have? We have a 16 by 2, 20 by 2, 16 by 2 display. We have an Arduino Pro, Nano, Micro, whatever. But this comes from a German company, AC Delivery. They're very fast and not so cheap as AliExpress, but faster, much faster. You order it and 2 days later it's there. And if you want to play safe, you can order it with Amazon. Maybe I should put a link in. It's not sponsored or something. Then some headers and stuff to. Don't want to solder the parts directly to the board because it's still a prototype and I guess there are mistakes. 2 sockets for the main IC because I don't have the large one. And potentiometer or variable resistor for contrast. The LCD display always need this. 3 100 nanofarad capacitors just for the voltage rails or for the voltage, and not for the rotary encoder. The rotary encoder, this is desoldered from something else. I'm running out of this. In diode, I'm using it for input protection, but maybe there's a mistake. No, we'll see. And another diode, this is an LED and light emitting diode, a standard red one. I just think I go with the red one. I could also go with blue, but I wanted to get with the red one. A little switch, a voltage regulator in 7805, another switch, a momentary switch, and a switch. Another header, and capacitor. You can never have enough capacitors. And 3 resistors, 330 ohm for the LED, 330 ohm for the backlight of the LCD, and 2.2K for the TLC chip. I think that's all. And as always, good practice, start with the lowest parts. So the lowest parts are the resistors. No. I think, should I make it nicely or just throw it in? And I need to check which one is which. Next time when I design a board, I wrote not the numbers. I really like 330 ohms. It's much easier than R1. What is R1? R1 is 330. It is straightforward. It's just through-hole components, no SMD components. So it's very easy to make. By the way, PCBWay. No, I'm not sponsored by them. And but I think they have something like a share project thing. So this board should be available on their website. If you want to build your own, should be not a big problem. But, well, yes, I see. Okay, I try to make it nice. I guess I should try this first. I didn't give enough clearance for the resistors. They really need to bend at the body of the resistor. It's my first PCB science about 20 years. 20 years ago, I am using Eagle. It was very easy to use. So the first try to design a PCB was Eagle. Nope, doesn't work for me. It's too long that I use it, and I have no idea anymore how to use it. Then I tried this free software from Altium. This is what I'm used for, this. And it was okay. I also used the software KiCad, of course, but also not my way. My way, PCBWay. And I really make the distance between the holes too small. The resistors doesn't fit in. Doesn't fit in well, but it's a prototype. You don't see what the mess I do. Wait, let me check the mess I'm doing from here. You see, that is a mess. Should not do it like this. But lesson learned. Use larger distance. But it's all about the contact, not the look. And that's what I say. It is live. So mistakes will be made. That is for sure. I could hold the leads, but I like when they fly. fly, little lead, black, whatever, fly through the sky. So, oh my gosh, really looks terrible, to be honest. I'm sorry. Now the next part is the diode. I think this should fit a little bit better. Yeah, sure. There I make bigger holes. Yes. When you solder a diode, you have the board designator, like the little ring there, and the diode also have the little ring. The little ring should be at the little ring on the screen. Match with it. Normally I don't solder like this mess, but no one will see. Oh, every viewer will see what mess I'm doing. I have to be careful, otherwise I have this in my socks. Could hurt. Now it's time for the little capacitors, the 100 nanofarad. They are ceramic capacitors, not polarized, so I don't need to check the the way I put them in. And cleaning the iron. Very important, always have a clean iron and clean tip. It goes much better. Okay, something to this PCB way boards. The quality is great. I really have to say this. And the solder flows very nice. The silk screen looks good. Oh, little spider on the table. No, a little fly. So, and one more. You see, this is very straightforward. It may be a little bit boring, but hey, doesn't matter. 1, 2, 3, 4. Doesn't fly. So, but do I save the sockets or put I in the sockets? From the height of the parts, the sockets, this IC socket will be the next. The IC socket, so just for beginners, on the silk screen is a little notch there. There's a little notch, and every integrated circuit also have a little notch. So later you have to make sure that the notch and this notch are in the same position. And usually also the IC sockets have this notch. Those have this notch. So best practice is to put the notches all together. Or if you wanted a little bit more, how to say, adventurous, then you just mix it up and maybe something explode. Some explosions are funny. Not always the best idea to let the magic smoke escape. To solder the IC sockets, also like if I solder the IC directly to a board, is just attach 1 or 2 legs. The rest now, and then check the alignment. Even this is already a little bit messy. I try to make it not too messy. Don't like when that. So, and then the funny part, soldering about, I think it was 28 legs. But this should not take long. Should go fast. after some, I always clean up the tip. The clean soldering tip is, yes, important in my eyes. I don't like when it is dirty, it takes oxidation, because then also the temperature from the iron tip doesn't transfer so well to the pad and the leg of the component you put in or you solder. So make sure the tip is cleaned and it works much better. Next part. I think it should be this little guy. Yeah, looks good. Don't fall off. I attach one leg to the potentiometer or the variable resistor. And here happened that while soldering it just move a little bit out. So I'm holding the component, heat up the one leg and press it. And if I didn't mess up with the distance between the holes for the resistors, this board would look nice after soldering. Now it looks messy. Ugh. It's not my work. So, okay, I didn't do this. I won't do it like this. Next part, the LED. I just stick the LEDs through the board. Okay. Another explanation for the soldering beginners. This is the alien, it's the LED. It has not the LED sign or something, but you see there's one side of the silk screen is flat. The flat one is the quartz cathode, minus. And on the LED, you have two legs. One thing to One way to identify the cathode is like out in German, it's very easy because short leg is K, kurz, and K is for cathode. Okay, Kathode in Deutsch, Cathode C in English. So, but in German it's kurz, kurzer Draht, Kathode, Kathode minus, weil ein Minuszeichen kürzer ist wie ein Pluszeichen. Muss man nicht verstehen, funktioniert aber gut. And that looks funny. And the long is the anode. There's also no things in Germany. And this is very difficult to see. Try it. If it focus, you will be maybe able to see on the plastic that also one side is flat. So put the flat on the flat or the short on the flat, or just check the schematics so you don't mess plus and minus on the LED. And if you mess it up, it happens. Wait, I got a message. Where? There. Oh, YouTube Studio say something. No impedance matching on the scope side? I think this guy is just writing something else. There's nothing to do with this video. And I messed up I messed up the LED. So even also one leg is soldered only. Heat it up and press it in. Very easy. The good is LED legs are harder than the resistor legs, and they fly much better, and I get the better cutters. So long distance shot. Oh, about 2 meters. Oh, almost hit the display from the laptop. So what I won't populate is the position for the DC inject, because I guess I mixed something up. But the next part is the switch is shorter. Is the little switch that goes here. Also here I should the holes a little bit bigger, but it's fine. Yeah, I have to redone this board, maybe not. maybe I will, and change the size of the R2 and the resistors, but it's maybe not so important, because I already have 10 of the boards and not so many parts. So now the last capacitor, can put it up, or okay. Now if I want to measure something, it's nicer when it lays flat and there's enough place so I can lay it flat. Scarce, but then I have to hold it. Cleaning the soldering iron tip. Nice, shiny. No, I don't put my hand underneath. Those. Focus, 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 focus. Nice, shiny tip. That is the best. And again, I have to adjust the position. Just solder one leg, position the part, bring the part where you want it, and then solder the second leg. Oh, 2 shots. Ooh. That was something like a bounce back. Or maybe this was too loud. Sorry for everyone listening with an headset. So, the voltage regulator. The pinout is in, ground out, but I have to check because I guess this is the position, so I can lay it down, but I'm not sure. So I will check for it. What is in, what is out, what is whatever. Even what is the position to switch it on? Oh, do we have some viewers? Sorry. Okay, YouTube is a little bit saying no. Good, schlecht. Why it is schlecht now? I switch off this one. Maybe I'm really using too much bandwidth with too many devices. I have no idea. But I'm not connected with wireless, I'm connected with cable. Someone there? Someone can write something in the chat so I can see if this works. This should be plus. From, did I mess up the condensator? No. The condensator, the capacitor, condensator in German, capacitor in English. I tried to mix the German and the English word. This capacitor is attached to the output. So the 100 microfarad capacitor is attached to the output. I can already see where the output pin goes. It's there. So in, out, in, ground out. Yep, my guess was right. It position is like this. But I will mount it like this. Lay it down. Even then, it's easier to go to measure. And before I insert the expensive chips, not the Arduino, the Texas Instruments chips are a little bit expensive, over €1 each. I need to check the voltage, output. Ooh, almost hit the laptop again. 1 meter. Also 1 meter. Nur dann, hi Nuri, yeah. First viewer, one of my coworkers. I just post in our group that I'm live. So, but I don't know why why YouTube still say the stream quality is not good. It should be better. Open widget. 1843. First it says very good, then good, and then merchandise? No, I don't have merchandise, sorry. What can I do to speed it up? Switch off the other computer. Still have 19% dropped frames. But this is also connected with cable. Yeah, we will see. Inside. This I will populate later. So this I also don't need yet, because when it doesn't work, this is my last rotary encoder. Won't mess it. And for the first test, I don't need it. And this I also don't need. For the first test, I just need this and some power. Get it from here. Switch off the prototype. So I set the, oh, that's a bit much, to about 8 volt. 8 volt should be enough. 2 little wires. Everything is almost reachable in my lab. That is good when you have a small lab. You can have everything have around you. You don't need to know where it is. Ooh. So, first moment of truth. Thus, is there some still 20 drop frames? Is there some life in the circuit or not? We will see. And if it doesn't work, maybe some magic smoke escape. And when it doesn't work and no magic smoke escape and I cannot find the failure, then we will make the magic smoke escape. Like magic smoke. Why not? Does it focus on me or on the cable? Yes. Even here, Nuri is very, how to say, co-worker, not say, Herr Singer. In this case, you can say Thorsten. So I was guessing that this is plus and this is minus, but then the diode is wrong. Something really went horrible wrong with the DC jack. Wait, need to make some sure. Maybe I have to remove the diode. This should not be unplugged. Oh, bring it in. So, this is ground. Ground is, where can I check ground? If it goes through everything. Oh, here, and pin 2 on the pin 2 should be ground. I really guess I miss something totally up with the power rails, but this is not so big deal. I can just manual. So this should be after switch on. No, the switch goes before. Okay, this should be plus. This should be ground. That is what I guess. I make some big mistake with the ground. So there is the... There should also be ground. Oh, wait. No. Where's the display? There. No, this is ground. Ground is pin number 0 is ground. But I don't switch to ground. No. No. I really guess I mix something totally up here. VCC. Doesn't matter. Just give it this little bit power. But I need to find out which one is ground. And then the other one is plus. I guess I mix up something so bad. Because normally this one should be plus and the other one should be like this. That's why I don't attach the valuable chips. So let's see what happened. Maybe nothing. We have 0 amps on the meter. Whoa. That already looks bad. Ooh. Okay, maybe still I miss up the polarity. Here's some wrong thinking, but doesn't matter. Happen. It would be also more than what I planned, but I really have problems to measure it. Lows. But if this is plus, well, I would be happy because then everything went right. I'm just a little bit confused about the layout because I didn't make the layout. I used the auto router. I know, should not. Okay. The whole circuit to switch on and off an LED. Don't ask me why. On, off, on, off. Oh, I can zoom. Maybe I should zoom in a little bit now. Hey. Found out something about my camera software here. Because I can zoom in. And I should drink my coffee. It's almost cold. So, on, off, on, off. These are also messed up. Should be the other way, but doesn't matter. So, now time to check the voltage. Just get the meter. So check it, of course. The display. The display needs know that it works. No, it does. Ooh. Upsala. Maybe I put a little bit too much into the 7805. It's burning hot. Okay, the input voltage was a little bit out. Killed the first component. I guess I killed it. On the input, I have nothing. On the input, I have -6. Something is really, really, really wrong. On the input, why it lit on? -6. The output, nothing. That's accepted because it's minus. This is not working right. I'm totally sure the LED was lit. Okay, plan B. That is what I guess what could happen. If I mixed up something there, the best place to inject the voltage to test the rest of the circuit will be this capacitor. So just bye-bye these cables. Bye-bye the voltage regulator diode here. Bye-bye the 7805. I know it's not the nicest way to do this. Still wondering why the light was on. It is nicely removed. Now I need to set the power supply more exactly to 5. Oh, that's okay. And solder it directly to the capacitor. So maybe it will explode now. Explode. Looks not so bad. I didn't plug it in wrong. No, everything is fine there. Yes, I'm injecting the voltage wire. Oh, and I should not go to 6 amp. So the LED. Where do I make the mistake? Did anybody see what's wrong? I guess I make a big mistake. But it's okay. Then we can look for it. So minus there, plus there. That works well. We have plus and minus. Where it should be. How can it be and it was not bigger? So then the LED is parallel to the it doesn't work. Should be not a problem to find a new LED. I don't know what happened. Should I switch off the power supply? Detach it. Special way to unsolder. A little bit new solder in. Just get it out. So now check again. On this side. So minus should be there, plus should be there. Okay. That's really, really weird. I totally mess it up. Totally mess up the schematics, to be honest. The only place it's right is at the capacitor. Good that it is right, otherwise it would explode. Yeah, that is not so worse. This can be. I will try it. Really want to make it work. But so many mistakes. Good that I plan to write and make a new schematic, because with the Altium software I was not very happy. And this is also a way to make it lit. So to make a new one. Oh, mess it up so bad. Los. Ooh. Guess I'm driving. Oh, with about 10 milliamp. That is not bad. So, but now I really need to check the polarity on the rest of the circuit, especially the display. So pin 0. Should be ground. And pin 1 should be plus. Oh no. No, it should be plus. Right. Oh my gosh, what happened there? Minus 2.6. It's also the wrong voltage. Just need to read. Do I have at the displays? I think there should be more than nothing. VCC goes to pin number 1. That's there. And the other one to the ground. But not 2.6. Should be a little bit more. 5 on pin 1. Pin 0. Something drives me crazy. Let me check the working one. Okay, if I have messed up so badly, that is possible. Something went totally wrong. This is the proof that I can do it. So pin 1 should be Nothing. Pin 2 should be +5. And here, not so good. Totally not so good. What's on pin 3? Nothing? 0, pin 0, 2. These, yeah, this comes from the cap, from the resist. What do we have here? Oh. Did I do what I guess? No. No, this goes nowhere. Nope, that is not right. And this goes there. This is ground. That should be not ground. Totally not. It should be totally not ground. This should be ground. Ground on pin. Maybe the Arduino at least has the right patches. But now I guess that I totally messed it up. Oh, totally. We in. Nothing. Ooh. Ground. Auch nothing. That is not bad. It is bad, but it's not so bad than if there's some voltage. Oh, +5 should be. Oh, go there. Everything. The plus goes. Oh, the Arduino looks right. Should be. At least the Arduino is at the right place. Okay, let me see. From there it goes there, and then it goes, the plus goes to the. That should be not there. That should be. What should be? This is joking. This is. There's minus. Now it is 5 volt there. Yeah, and this is the mistake. No, don't switch off. I still need you. Okay, pin 0 on the display should be ground. Pin 2 should be VCC, but it's not VCC. It's half of VCC because it's V0. Voltage divided by the resistor here. What did I mess up? And the third pin goes all the way there. This looks like ground. No. What the hell did I mess up so badly? Okay, I mixed up totally. This one is Gonski. Maybe the Arduino is right, but not sure. At least it has the +5 at the right place. This I won't check anymore. And there's something totally mixed up at the display. It's so I guess this is a lost. So my first PCB doesn't went out well. At least the light now goes on. And the dollhouse still have to use the prototype one. But that should be not so bad. Could happen. Makes me a little bit sad. But this still works. So that's all for today's video maybe. In the next soldering video I will solder something pre-made, and this it has nice corners. I can use them for great size for coffee. This is a great size. It's a coffee cup holder thing underneath. So it's now nicht spät. 7:15. This doesn't went well, but hey, it's a little bit what I expected. I really don't know what I mixed up, but I use this schematics, but why it's not? What should go wrong? I just want to see if the light goes on from this. I just set the amps to very low. Because 128 milliamp, nothing should broke. And if it breaks, these are the cheap displays. Because on the schematic it's right, and only the parts with the connector here it was not sure, but okay, no light on the this, doesn't light up. No magic smoke. 58 milliamp is nothing. So the outer pin should be minus, yes. Do I still have voltage there? It is. No, it was plus. That's right. No, I won't give up now. Let's see, check a little bit what's going on. 5 volt. 5 volt. 5 volt. And on the schematics, it's really the resistance goes to the anode. And here it does someone have an idea what happened there? Yes, hello Alpha Mac. Yeah, you catch the the sad live stream. because I make some mistakes with the board design here. And checking the schematics again and again. And normally the schematics should be the same like the board. And I don't think that PCB way messed up. So I guess I messed up. But let me see if it is a little bit in the shot. Too many stuff here. Oh, my face is in the way. Wait, let me move on this side. Okay, from the schematics, maybe I imported the wrong module with the numbers. The numbering is 0 to 15. It's the same like 1 to 16. But already on the PCB, it looks like something is shifted. And like the R2, one side is just at the plus of the capacitor. And if you look at the schematics, that is right. This side of the resistor is plus 5 volt. 5. So let's attach this to the ground. To reverse engineering my own things. So, and here at the capacitor, just zoom out. Just on the capacitor, I should have my 5 volt. And I have it. It's there where it's supposed to be. Then the 5 volt goes down to the resistor. Still there. On the other side, of course, is also still there because of no load. This side of the resistor goes to pin 14 of the LCD display. There's pin 14. But pin 14 goes, I guess it's ground. And then the last pin is not connected anywhere. So maybe that's why you should not use an auto router. But I think the problem was the bibliothek, the library I use in this Altium software and this free online Altium software. Should not use it. Later I use Easy EDA from JLC PCB blah blah blah. It was much easier to use. And yeah, so I totally messed up at this thing here, because now from the view of and I also cannot view the schematics because I forgot the login for the Altium software. So here, I guess now it's shifted there. There's the 5 volt. So everything is shifted. This is pin 1 then. This is not pin 0, it is pin 1. And pin 1 is VCC. That is also right. But it should not be pin 1 with VCC. Pin 0 should be VCC. But so this whole thing is moved. I guess now the rest. I have enough of these little things. Just give it a try. It's so tight fit, it should fit in. Just want to see what the Arduino does. Okay, it does nothing, but also not getting more unnecessary power. VN. Yeah, also nothing there. Why? Because it goes. VN, then ground. No, VN is there. Hey, VN is there. We get to 5 volt where it should be. Maybe the audio router messed up. Yeah, it's totally flawed. Okay, the audio router. What should I do? No? The microphone is hanging there, so it could be a little bit weird. But audio still looks good. I'm just dropping some frames. Yeah, okay, no problem. Yes, but I still have time. I still go through it. Pin 1 is +5. That's right, for the Arduino part. Then the second one should be ground. And everything is shifted. Of course, this is ground. This is pin 16 or pin 15. No, pin 16 on the board. So the connector for the LCD display is shifted. Well, is there any way to... No, that won't work. The last pin is not connected. And I need to shift it over this direction, I guess. Let me see if it lights up. No. No, it's not just messing around, not thinking or measuring. But doesn't matter. Yes. I have voltage now there. And the outermost is ground. And the inner is plus. So if the diode inside this is still working. Oh, it's not very bright, but I can see it is working. And I plug it in like this. Yes, now it lights up. But it doesn't have ground. That should be not a big problem to give it ground. There. So. Don't think that this will work. But at least I will get power to the LCD display. I'm using the socket for it. So just get me this in. Yeah. Standby mode. Oh, the batteries of the camera still hold. So far I found out that the socket is shifted something, I guess in the library, or yeah, I didn't check it after. Yeah, that's maybe why you should hand route your board, but I'm too lazy for it, so I won't do it. I won't hand route. Just want to double check it after auto route. And just shifted everything to the left side. Maybe everything, not sure yet. But now, when I plug it in, I already get which I need later. The backlight already lit up from the display, and I'm not sure if you can see it from here. And that shows me, and it's a little bit much, and it doesn't run hot, so it should be okay. Tell me, I'm always looking at the watt, so after I plug in, I need to check how many amps the circuit take, and I have to wire up the ground for the circuit by myself, because there where plus should be, or the ground should be, was the plus 5 volt, and then comes the setup, the contrast voltage. So it looks like everything was shifted there, also no, there, this direction. So yeah, pin 0 doesn't exist, maybe in the library, or in the library, the footprint library was different from the part library. Yeah. Next time I should use the easy EDA software from JLPCB. And now I get about 20 milliamp totally. That is still fine. And this is pin 1, 0, what I write there. And this should be ground. And ground, it's easy. I can just get from this place here. And I guess the other problem was maybe the get a little bit more now. No, a little bit is good. No, it's still okay, I guess. Yeah, I get the dotted lines on the display now when I turn the contrast. So if the shifting is not too bad, there's still a little chance that it works. Even it looks terrible now. Before I plug in, I will check the voltage at the expensive TLC chip. This is the only expensive part. The rest, the Arduino Nano thing, it's very cheap. I should also not try to print it. So for the Arduino, it's easy, just put it in front of me. VIN should be there, and ground should be the next VIN. Just hit the board. Okay, VIN should be there, and ground should be there. Looks good. So Arduino should be not big trouble. The TLC chip. 21 is VCC, 22 is ground. That is easy. Oh, I can just check it on the capacitor if I have there. Yes, the capacitor is fine. And then 21, 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's one. There, it's pin 1, not there. 14, 15, 16, 17, 18, 19, 20, 21, and 22. 21 is plus. Expect -5. Yeah, works. So the Arduino and the other chip, the TLC chip, looks fine. The voltages. Then it's really, maybe it's only the display. messed up. Not sure yet. For nice alignment, I put this sockets first into the Arduino, like this. Then stick it to the board. Then hold it. Then get some solder. Do some funny things with your fingers to get one leg soldered and one more leg on the other side. I'm not Big Clive. He can do it so well with one hand. Me not. So, double check your schematics with the PCB. That is what we learned, what I learned today. Maybe you were screaming at me. Doesn't matter. Clean my tip. Check if something is going on there. Okay. Yeah, but the rest of the 9, oh, did they send me 20? No, they sent me 10. I will really use as the coffee cup under things. The things underneath the coffee cup. Let's see. So I was really wondering if this has still some life in it. So just power on. Oh, like you want gas, but I see already. I see already. Wait, I need to zoom in. That what first looks like a totally fail. It's now just a little fail, but not so bad because look at this. Something to turn the there. I need to check if you can read it. By the way, I programmed the Arduino before, of course. So this way totally mess up. The power stuff totally mess up. But the Arduino looks right. Okay, partially. Because I can desolder it if it doesn't work. So let me see if we still get more life out of it. Get the Arduino in, the rotary encoder in. And the on the board I write back, but at the moment in the software, how the software is configured, it is for select. So this pin is important. I guess I mess also up something with the knob here. Yeah, we will see. But now you can believe me, it's live. It's really, really totally live. Nothing else. Nothing else than live. There's some, oh, only, actually more like one bodge fire. Sync for revision. No, you see later. Should be not too excited now. For a revision 0 board, one bodge wire should be totally okay. No. Oh, oh, it changed the numbers. It's already doing something. Does it switch to the mode? Yes. Whoa. Huh. I'm not so bad as I thought before. Should I plug in the TSC now? Yeah. It should go wrong. Still no magic smoke. Kill the LED at the beginning. But it doesn't have magic smoke. So sorry for this. So I check already the voltage. It should be okay. Again. Oh, it's not burning. I need to measure something if the LEDs is. They are connected as common anode. Common anode, yes. Channel 1. Oh, zoom out so you can see the rest of this table. This one. Who is there? Hey, now it's getting funny. No, not really, but it is started working. No one is watching me. If you're watching, please subscribe and hit the bell and maybe consider going to the Patreon page. So, I need more rotary encoders. Let me... Or should we go to the oscilloscope? No, we do it with this. Full, yeah. Okay, channel 1 should have now some life. Oh wait, let me first check if I have the +5. Yeah, I have the +5 there. And I have something there. And less there. So, on pin number 1, I should have live. No, not mine. I switch it off. Getting some LEDs. Which one should I get? Not right. Oh, idea how this look. This fit. But I will see. Should be okay. Channel 1. Full. It's on. Off. Full. Flicker. Doesn't look so bad. It is doing something. At least. So, should I attach it to the original dollhouse? Oh, what is the time? Almost 8? Or just show you on the demo board that it works? Unbelievable. Or should we just stop here? I think I will go through the just throw in the 16 LEDs. So. Oh, no. I could just try something. Throw in the 16 LEDs. Unbelievable. That is when you do something you should not do this way. I really should check the layout. Or make it by hand. No, no. I'm not the guy who lay out PCB by hand. That's a long time ago. And with smaller things. Really want to give the other company JPCL a chance or a try. When I was making this, I was also downloading the EDA software from there, because after I uploaded, I really don't like the Altium free software stuff thing what they have, and I was checking another one, and really have to say this easy, I think it's called Easy PCB, I like already much better than the software I use. Also the export was not easy, and then upload to PCBWay was not easy with this. So, and it's not saved locally, so I even cannot recheck what I'm done on the PCB because I forgot the login for this site. So it doesn't matter. And to be honest, the project, if this work, I don't think that I need. I should make another one. Maybe I want to make an instruction on instructables. But on the other hand, it is very positive that something doesn't went well at the first try, because that is how you learn, or how I learn those things. Learning by mistakes. Now I know that there is a difference between the symbol in the schematics and the, whoa, even it's messed up. I want to make it a little bit nicer. And the library stuff. When I used the DOS software, I think it was still DOS with Eagle, at work or at education time, was maybe also longer than 20 years. There was also auto routers, but the thing with the libraries was not so complicated. There was not pre-built libraries for the parts. So you make it easy. You have, you just, for most of the parts, or for the ICs are not, no, they also have this, but built in already. So I just guess it was easier. Here you have, it doesn't find this, and then it looks weird, or it just don't like it. But now I learned something where I have to be careful on which place. So next time, when I design a PCB, I will make it better. And I will use JLCP PCB, another one of the Chinese PCB companies, because no, the experience with PCBWay was not the best for me. I was writing them already 2 weeks after it doesn't arrive. I tell them it doesn't arrive here, please help me, and they let me check. They say, oh, we cannot do anything, you have to give it, you have to say it is lost. I do this, and then I already give it up, to be honest. And then after about 2 months, they contact me and say, oh, we just see in the system it doesn't arrive. Should we refund or resend? I choose resend. I want to give it a try. And then it arrived after a few days. No problem. So, okay, this could happen. So it's not a failure or not a problem from PCB way. But while waiting and trying around, for me, I like the integration from the easy EDA software to the JLC PCB stuff. So seems to be quite easy to order. You can order it just from the software. And while trying around with it, also looks like you can order the parts you need from them or through them, or it's synchronized with the project. So many things I like on it. Even won't use it, but I like it. So yeah, leave what you think in the comments, and I guess I will redo these things. Yeah. Oh, still one come out twice, and give it another try. Make a nice PCB. So time to power this on. Oh, maybe I should switch up these two lights now, so you can see it a little bit better what's going on here. Okay, it just started like this. Ooh. This can make short circuits. Well, a little bit of reflection still. Maybe this is a little bit too close. Like this, maybe. Yeah, doesn't look so bad. And now let's try channel 1. I guess it's this light. Off. Oh, there, select. Full brightness. I set it not really to full. I forget how many I'm limited. Or PWM or flicker. PWM you have to select, and then you can set the value. I'll set it to 10. Select again. You can change the channel. Channel 2, flicker. Channel 3, full. Channel 4, full. Now I'm too lazy to always set up the PWM value. More brightness. Channel 6. That would be the... That looks nice. Yes, channel 6 flicker. Channel 7 flicker. Channel 8. And you see all the LEDs flicker at the same no, I think I forgot how I do it. It's not totally the same. I tricks a little bit, but not so much. It's not random, okay? But it's also not the same between the LEDs, but it has used the same table. But I think I make something. Full. Number 9. Flicker. Number 10. Can you see it? Yeah, it's not so... Maybe it's too bright here. Number 10 will be full brightness. Number 11, PWM. Let me see how many steps I made. Where was it? Like 100. Maybe it was like 100. So, number 12. I should have a random program that the lights just randomly switch on and off. But this is just a software part. This is quite easy. And you cannot mess it up. You can, but not so easily. Oh. And flicker. Flicker is always nice. Or should I call it candlelight? The simulated candlelight. Oh, and I think I forget one. No, no, no. Still. Oh, what is with 14 and 15? Hey, guys. 14. Hello, maybe there's not enough solar. First guess is something is horrible wrong with this channel. Or I mess up the direction of the LEDs. Or the LEDs was broken. These are cheap LEDs, so could be that they're just broken. Glass was there. No. Okay, that's weird, to be honest. Should measure it. Um, 14 was off. And 15 is flicker. Full. 14 and 15 are full now. Oh. Yes, it's there. It's there. I guess I make something wrong. No, I don't unplug the power now because it's a little bit annoying to lose. To set up all the lights on. So I just do it like this. What should go wrong? Everything goes wrong. Doesn't want to fit in. Okay, it's lit. Then it's time for just it's okay. It works. Almost. How long I'm streaming now? 2 hours? Almost. Shit. The long one is the little one. Okay. Then the LED should be in this direction. Yeah, also lit. So it's just for the test. Oh, now YouTube is complaining again that it is not fast enough. No. The colors doesn't look so good. Ah, it's okay. The audio is still there. Maybe too loud. Maybe not. Channel number 15. Go to Flickr. Works. And channel number 14 also Flickr. Should have something like a switch to set everything to Flickr. Yes. Okay. Finished for today. I just go to the conclusion or something like, what would you do different? Maybe not soldering with power on. Something like this. Not afraid of it. I would say, hope you learned something. Oh, but maybe you also learned something. I learned something. I learned that I should listen to my stomach feeling, Bauchgefühl, about the software I used. This was the free online version of Altium. And it's not my software. It's not like I have to use it because it was easier than Eagle and KiCad. But then it doesn't get used to it so much. And after a while, after this project was done, I just tried the other software and I have to say I like it much better. So I need to check if I'm making the board with this, if also something like this happened. But when I do the new board, then I will check special the connectors or the pinout, especially the voltage. So for everyone who just go to the end of the video, want to see what happened and not watching the whole stream, I was already ready to give up because the power supply thing was something wrong and I didn't check it detailed. I just used the capacitor here to inject the voltage. But then I realized, wait, I just zoom out so you can have more of the schematic. I realized that doesn't work, and I was measuring not the voltage that has to be on the display. I didn't measure the voltage for the backlight. The ground pin was not there where it should be. I realized everything was shifted to this side, or pin 16 on the PCB was not connected to nowhere, to anywhere. Pin 15 on the PCB, or 14, whatever, how you count it, was connected to ground. And that was really, something was totally wrong. The counting from the library, from the schematic, is 0 to 15. The counting on the, actually, maybe on the schematic, on the layout, there's another library for the pinout. Sorry. There was maybe the failure. It was maybe counting from 1 to 16. But 16 I didn't populate because it stopped here at 15. So 15 is there where it should be. But when you count from 1 to 16 on the board, wait, I can, like, doesn't get out. So that's why the board has the ground cable here. So if this is pin 0 and this is 15, everything is fine. But on the library, this is not what should be on 0. This is what should be on 1, on 2, on 3, and 5, on 16, also 16, it doesn't exist on the Schaltplan, on the schematic. But it exists maybe on the library. I cannot check it again, so sorry. But 16 here is not, it's not connected to anywhere. It's just sitting in the air. It should be the cathode of the backlight. It's not. The cathode of the backlight is one here. It's there where should be the anode of the cathode of the backlight. So I was measuring and doesn't get the voltage. That was weird. Also, in the beginning here, what should be pin 0 with ground was VDD. It's called VDD on the schematic. The 5 volt. But it should be ground. But ground is there. It should be there then. Or happen is there. So that is, after a while, it just come to my head that something may be wrong with the numbering. Luckily, the rest of the chip was numbered right. Otherwise, it would be totally a mess. So I was already ready to give up, to just throw it away, to just say, okay, quit, enough time. But not so good in giving up. So I just check again and think about what can I do. The solution is the bodge wire. Otherwise, it's only one bodge wire. It's not so bad, but it's bad. So I just shifted the whole display this direction. When I plug it in now, I don't want to restart, shit. But I think I have to plug it in like this. Now it's, yeah, of course, it doesn't show because I have to restart the CPU. But this I don't want to make. Then all the lights are off. Otherwise, I'd send another reprogram it with every light on flicker. Maybe let's give it a try. Hey.